part 2 of the Unit 10 review, number 15. So again, you can tell which formula you should use based on where the vertex of the angle is. So here we see 68 degrees, so that's this angle.
Oh my God.
And the vertex of the angle is sitting on the circle. So when the vertex of the angle is on the circle, that's called an inscribed angle. And the angle DLF, actually it's just 68 degrees, is equal to half of its intercepted arc. So the intercepted arc is from here to here. And that is the arc that we're being asked for, is the measure of arc DF from D to F. So, of arc DF. Alright, so if I'm solving for arc DF, 68 degrees equals half of DF, so then I just multiply it by 2. The 2 and the half cancel. 68 times 2 is 136 degrees. So 136 degrees equals the measure of arc DF. All right. Number 16. Let's look at what we have. We have an angle. We have information of an angle. And that angle is sitting with the vertex on the circle. So it's inscribed. And we can see the arc, the included arc of that angle is 91x minus 1. So we can set this up as the angle is equal to half of the measure of the arc. And I can plug in the information. 46x minus 1 is equal to half of 91x minus 1. Alright, so again, I can get rid of the half by multiplying by 2. I'm going to cancel that. And then do the other side by 2. So make sure you put that in parentheses. And then I'm going to distribute the 2 into the parentheses, multiplying both pieces of the left side by 2. So 2 times 46 is 92. So 92x minus 2 equals 91x minus 1. Alright, so now if I get all the x's together, so I subtract 91x. So then x minus 2 equals negative 1. Last step is to add 2. Well, the last step to find x anyway. So x equals 1. But this didn't say find x, did it? It said find arc wx. So here's wx. That's the included arc. So arc wx equals 91x minus 1. And since x is 1, that's 91 times 1 is 91. And 91 minus 1 is 90. So arc wx equals 90 degrees. So that wraps up included angles. The next section this is probably the hardest type of problem you're going to have on your test, is whenever you see the circle with all these little lines in it. Pretty much just telling you that you're going to use Pythagorean theorem most of the time. Find the length of the segment indicated, round to the nearest tenth. The theorem that goes along with this is that a radius is a perpendicular bisector of a chord. So we do have a chord. It's just a segment from one part of the circle to the other. So this segment is a chord. And the radius is a perpendicular bisector of a chord. So that means both parts of the chord are equal to each other. So I guess I'll call it the right side, just kind of the lower right side. If that's 13.4, then the other one is also 13.4. And I need to find out what x is. But before I can do that, I need to find out what this other piece is. I'm just going to call this piece A. It doesn't really matter what letters, just I can't call it x. And I see I also have a radius. Right there. I have a radius of 16.2. So if I know the whole length of A and X together is 16.2 because it's a radius, if I find out what the value of A is, I can subtract it from the radius and the leftover amount is X. So I need to use Pythagorean theorem to do A squared plus 13.4 squared, and that equals 16.2 squared. You have to make sure that the longest part, the part across from 90 degrees, is the C. All right, so first I'm going to subtract over the 13.4 squared. So I can just type it all in at once. So A squared equals 16.2 squared minus 13.4 squared. And that is 82.88. So you need to make sure you give it at least one extra decimal space whenever you round before you get to the end result so that your rounding doesn't get messed up. All right, so I have A squared, but I need A, not A squared. Because clearly that part of the triangle is not 82 if the longest piece is 16. So I need to take the square root. And A equals 9.104. And now that I know that, and I know that the radius is 16.2, I can subtract the 9.1, and that will give me the value of x, which is 7.1. Equals x. All right, so when you see that shape, remember you have to use Pythagorean theorem. It just depends on where the x is as to whether, if the x would have been this purple piece that I labeled A, then I would have been finished. I wouldn't have to do this piece. But if it's the way this problem is, then you do it the way I just did it. All right, looking at number 18. This is pretty much the exact problem. It just has different values. So again, we have a perpendicular bisector. You can see the 90 degrees. That's another clue to what kind of problem you're doing. So that you have the radius, and then you have that. So but you don't even need that for this. Then, because the placement of this 35.2, that's a diameter. It goes all the way across. And you can see because it's right next to that dot in the middle. But I need to know what the radius is, because I just want to deal with this piece. I don't want the whole thing, I just want half of it. So if I do 35.2 and I divide it by 2, then it's 17.6. So this part is 17.6. And then I can solve for A, if I call this A. So A squared plus 15.8 squared equals 17.6 squared. Subtract. So A squared equals, I type in 17.6 squared minus 15.8 squared, and it's 60.12. And then I'm going to take the square root. So A is 7.75. But I need to find out what x is, and x is part of the radius. So if the radius is 17.6, and I subtract 7.75, then I get 9.846. It says round to the nearest tenth, so the 4 tells the 8 to stay the same, so x equals 9.8. All right. So that's when you use the Pythagorean theorem, and the radius is a perpendicular bisector to a chord. The next section, find the measure of the arc or angle indicated. Assume that lines that appear to be tangent are tangent. Okay. So here we have the question mark, what we're looking for. So we're trying to figure out what this angle is. What is the measure of this angle? All right, so here's the angle. And the vertex of the angle is sitting on the circle. So that means this is inscribed. And an inscribed angle equals half of its arc. So angle equals half of the arc. But the arc doesn't have any information. So first we have to figure out what that is before we can start solving. But we see we do have this 218 degrees over here. And since this entire circle is being used, none of it's been cut off. Like on number 20, you see like some parts of number 20 have been cut off. That's cut off, and that's cut off. So that's not an entire 360 degree circle. But on number 19, it's using the entire circle. So I can say 360 minus 218, and it's going to give me 142. So that means this arc over here has to be 142 degrees. And now I can solve for the angle. So angle STU is equal to half of the arc, and the arc is 142 degrees. So that means that angle STU is 71 degrees. All right, so then on number 20, again, we're looking at the vertex of the angle to see which formula on the formula sheet we're using. On number 20, the vertex of the angle is outside the circle. So here's the angle, a secant, and another secant. Make up this angle of 48 degrees. The vertex of that angle is outside the circle. So when you have an angle outside the circle, the formula is that the angle, in this case, is equal to 1/2 of the big arc minus the little arc. Do the big one. So the big arc is furthest away from the angle. It's 167 degrees. And the little arc is the one that's closest to the angle. There's a question mark, so I'm going to make that X. So I don't really need the parentheses, the second set of parentheses in this one around little, because it's just an X. There's nothing to distribute. And that's angle. And the angle is 48 degrees. All right, so to solve this one, I need to get rid of the half. To do that, I want to multiply, oops, let me make this smaller. Multiply by 2. Then 1/2 and 2 cancel. If I do it on one side, I need to do it on the other. 48 times 2 gives me 96. So 96 equals 167 minus X. So then I'm going to subtract 167. It's going to give me a negative number, but that's okay. Don't worry about it. Just go with it. I get negative 71 equals negative X. So if negative 71 equals negative X, that means that X equals 71. Because if you want to get rid of that negative, you multiply by a -1 and it cancels it out. And then you do it on the other side and it cancels it out. So X equals 71, which is the measure of arc TV. So I'm just going to leave it as X. I'll just put X here. There we go. Now we're good. All right, so that's the angle equals half of the big arc minus the little arc. All right, and that's when your vertex is outside the angle. So you can see on number 21, we have the same thing happening. It looks a little different. If you just look at the picture, whoa, what happened? There it is. If you just look at the picture between 20 and 21, the pictures do look different. 20 is made up with 2 secants that slice off part of the circle. 21 is made up of 2 tangents. But it's still the same formula because the vertex is outside the circle. And that's how you're identifying your formula, is based on where the vertex of the angle is. The angle is here. That's what we're looking for. I'm going to call that X. And the vertex of that angle, point L, is outside of the circle. So the angle equals 1/2 of the big arc minus the little arc. So we do need to figure out those 3 things. We're given the little arc in this one. The arc closest to the angle is 124 degrees. What we don't have is the big arc. But that's something that's special about tangents, relationship of tangents, is that it uses the entire circle. So I can easily find it by saying 360 minus 124. And that is 236. So this arc is 236 degrees. So then the angle x is equal to 1/2 of 236 minus 124. And we can start by multiplying by 2. Well, you know what? We're solving for x. So why don't we just solve everything on the right instead of solving the equation? We'll just simplify. You can do that. But I think this one would be simpler just to say half of 236 and half of 124. So then we would have x equals 112. No, oh, okay, I did it slightly different. I did it even different. We'll change that up again. I like the way I did it on my paper better. 236 minus 124. Just simplify that first. That is 112. So x equals half of 112. 112 divided by 2 is 56. So x equals 56. And then on number 22, again, you look at the placement of the vertex of the angle. So identify where is the angle. Right there, the angle is 51 degrees. And the vertex of the angle is sitting on the circle. If it's on the circle, it's an inscribed angle. An inscribed angle is equal to half of the arc. So the angle is equal to 1/2 of the arc, the measure of the arc. And the arc is included. It's inside the angle. So there's the arc. I don't know what that is though. But I do know what the rest of it is. So again, if I know the rest of it, and the circle's 360 degrees. Sorry, I don't know why I just said that. I was thinking one thing and saying a different thing. Well, we'll get to that in a minute. All right. The only thing I'm given, I'm going to change that question mark to an X, just to make it easy. The angle, 51, I'm going to plug that in. 51 degrees equals half of the value of the arc, which I'll call that y. It's better just to have a single letter. So I can figure out what the value of y is. By multiplying by 2, I'll cancel the half. If I do it on one side, I have to do it on the other. So 102 equals the value of y. So now I know the arc measure, that y equals 102. But that's not what I'm being asked for. I'm being asked for the rest of the arc, not the included arc. And that's where I get to the 360. I know a circle is 360 degrees. I subtract the given piece, the 102. And what's left over is the remainder of the arc, which is 258. But again, I started with where's the vertex of the angle. That's the best way to start almost all of these problems. Where's the vertex of the angle located? Even though I wasn't solving for the angle, and I wasn't even solving for the included arc of the angle, it was still the best place to start. Okay, so looking at number 23. This time we have a tangent and a secant that make up an angle. So the secant slices off part of the circle, so I know anything, I'm not going to be subtracting an arc from 360 because I'm not using the entire circle. I've just eliminated this section. It's gone. Here's the angle is 70 degrees, and the vertex of the angle is outside the circle. Since the vertex is outside the circle, then the angle equals 1/2 of the big arc minus the little arc. And I know the value of the angle is 70 degrees. 70 equals 1/2. I know the big arc. It's furthest, the biggest one, it's furthest from the angle is 220. What I don't know for this problem is the little arc. I'm going to call that x. So now I'm going to solve it. Instead of just simplifying, I'm going to solve. I still want to get rid of half, so to do that I multiply by 2. 1/2 and 2 cancel. I do it to the other side as well. Gives me 140 degrees equals 220 minus x. And then I'm going to subtract the 220. So negative 80 equals negative x. If negative 80 equals negative x, then x equals 80. Or 80 equals x. The negatives cancel each other out. So the value of the little arc is 80 degrees. All right, one more of these. Again, it's a secant and a tangent. The angle that's what I'm solving for. The vertex of the angle is outside the circle. So the angle equals 1/2 of the big minus the little. Since I'm solving for the angle, this is x equals 1/2 of the big arc, 165, minus the little arc, 79. All right, so all I have to do on this one is simplify because x is already by itself on the left. 165 minus 79 is 86. 1/2 of 86 is 43. So the angle x equals 43 degrees. All right, so that's all of the angles and arcs part of the review. The rest of it is equations of a circle. This section, number 25. Use the information provided to write the equation of each circle. So make sure that you know where you have your formula sheet. The equation of the circle is at the bottom of the page. And that is x minus h squared plus y minus k squared equals r squared. So h, k, and r are the three things that you fill in. And hk makes up the center. So if I'm given the center 1, negative 11, then h equals 1. K is negative 11. And the radius is 1. Be careful with the radius of 1. You also want to make sure you get r squared. R squared, 1 times 1 is also 1, so it didn't really matter too much in this problem. And then you're going to write your formula with blank sets of parentheses. So x minus blank squared plus y minus blank squared, equals, okay. So if I do it that way with my blank parentheses, you really don't need this one. We'll just do it that way. I think that's probably the easiest way not to make a mistake, is do it like this. H gives you the first blank, K gives you the second blank, negative 11, and R gives you the third blank, 1. Then you write it one more time, x minus 1 squared plus y plus 11 squared equals 1. I'll do this again for number 26. Again, we have h is 13. K is negative 8. And R is 4. So then you write it out. X minus blank squared plus y minus blank squared equals blank squared. Plug in your 3 values. You have a 13, a negative 8, and a 4. And then simplify it. X minus 13 squared plus y plus 8 squared equals 16. That's really all there is to it with the equation of a circle, writing it. The only other way would be if you're given the circumference. Before you can write the equation of the circle, you have to calculate what the value of R is. And you know that C equals 2 pi R. So if if the circumference is 24 pi, then 24 pi equals 2 pi R. And then you'll solve for R. So you divide by 2 pi. 2's cancel, pi's cancel, pi's cancel. So then the radius, R, equals 12. And we already have H and K. So then we just write the equation of the circle. X minus blank squared, y minus blank squared equals blank squared. So H is 0, K is 5, and R is 12. So whenever you have a 0, you don't need any of the parentheses. It's just x squared plus y minus 5 squared equals 12 squared, which is 144. Alright, so one more of those. It works just the same. So you have H, you have K, and you have to calculate the R from the circumference. The circumference is 6 pi. So 6 pi equals 2 pi R. So you're going to divide by 2 pi. Pi's cancel, 2's cancel, pi's cancel. 6 divided by 2 is 3, and that equals R. So the radius is 3, and then you have the 3 things you need to write the equation of the circle. So, stopped working. X minus blank squared plus y minus blank squared equals blank squared. Plug in the 13, the negative 8, and the 3. And then write it again. x minus 13 squared plus y plus 8 squared equals 9. There's really not much to writing the equation of a circle, and those blank parentheses make a huge difference than trying to do it without them. Alright, so last I'm just going to do one of these. Identify the center and the radius of each and sketch the graph. So we know the center is at HK. Since this is a negative sign, it's x minus 2, then I know that h equals 2. And then I have y minus 1, so that means that k equals 1. So the center of my circle is at the point 2, 1. And then if 16 is r squared, then that means that r is 4. So 1, 2, 3, 4, and then I go up 4, and I go left 4, and down 4. And sketch a quick circle. Same thing with the next one. Since this one's a plus sign, this is x minus negative 4, so h equals negative 4. And k equals negative 3. And r is the square root of 9. So r equals 3. So go to negative 4, negative 3. And then 3 spaces up, 3 spaces over, 3 spaces down, 3 spaces over. And there's the circle.